Okay, we're going to learn about the electromagnetic spectrum, which is a big long word that means all of the energy that comes from the sun that travels or radiates through space. Now wait a minute, you hear the word radiation, and I know some of you are thinking radiation, nuclear waste, horrible stuff. No, 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 no. The word radiation simply means energy that travels through space, like the energy from the sun, the light and the heat that you see every day. Daylight, heat, you're receiving radiation. That's all it means. Energy that travels through space as waves. Some other words you might see are radiant, radiate. The energy radiates. Right, so the word spectrum means everything. When we're talking the electromagnetic spectrum, we're talking about all the energy that comes from the sun. And only a little bit of that is the part that we see and we feel. There's a whole lot more to it that we're going to learn about right after this. Okay, EM, electromagnetic waves, all travel at 300,000 kilometers per second. Wow, that's fast. That is so fast that electromagnetic waves will go around the world 6 times in 1 second. Wow. Seems like light travels instantly, but it really does take a little bit of time. That's just so fast that we can't even process it. When you think about it though, the sun itself is millions of miles away in space, and in fact it's so far away that light traveling at the speed of light, which is 300,000 kilometers per second, actually takes 9 minutes to reach us. So if the sun were to go out, which is impossible, but just say it could, we wouldn't even know for 9 minutes. We'd still be receiving all of that light and heat that's traveling its way toward the earth. 9 minutes, that's how far. The sun is 9 light minutes away. So, as I said, that's the speed of light. All the energy that travels from the sun travels at the speed of light, the electromagnetic spectrum. That's it. As I said, the light and the heat, all the things that we see and we feel are only a tiny little portion of it. On the next frame here, you're going to learn about the whole rest of it. Which, by the way, we have a lot of uses, and I know you're familiar with these. Okay? But this is how it's laid out. This is a picture of the electromagnetic spectrum, all the waves of light and heat and everything else that comes from the sun. If you notice, my lines are bigger here and then they get smaller. That's to show you that the wavelengths of all the energy get longer toward this end and lower energy as you get to infrared, microwave, and radio waves. Longer wavelengths, lower frequency, lower energy. Now on this side of visible light being right in the middle, that's all of our rainbow colors. You know, red, orange, yellow, green, blue, indigo violet, Roy G. Biv, if you remember that. Those are all the separate wavelengths of light that we see. But all those wavelengths makes a tiny little fraction of the electromagnetic spectrum. Now on the other end of light, you get ultraviolet and X-rays and gamma rays. Those, as you can see, as you go toward the other end of the spectrum, the wavelengths get shorter, and the energy, the frequency and the energy of these wavelengths is higher. So higher frequency, higher energy, shorter wavelengths. Longer wavelengths, lower frequency, lower energy. Okay, now how do we use some of these waves? Well, let's see, radio waves, we use these for communication. And I'm going to write down some things on here. TV, radio, communications in general. Okay. When we get to the longer end of the spectrum, that's what we use. Now microwaves. Microwaves, besides being used to heat food in a microwave oven, are what your cell phone signal is transmitted on. So let's write cell phones, and also cooking. Okay. Heating up our food in the microwave. We're radiating our food basically with microwave energy. Infrared is heat. The heat that you feel from the sun or from any source is infrared. Now we can't see that, but we can certainly feel it. So I'm going to write heat. However, there are some animals that can see infrared, seeing with their eyes or with their senses. Snakes, for instance, can see a nice warm little mouse crawling around at night. That's how they can get their food. They actually visibly see the heat coming off the mouse's little warm body. Pretty neat. Okay. Visible light, I'm going to draw a picture of an eye right here. A few little eyelashes. This is what we see. All the colors, light and colors. Everything we see is that little tiny bit. By the way, the colors of things are only what we see reflected back, because all of the sun's energy with all of the colors is shining down on, say, a tree, a green tree, and it's all being absorbed, and the only thing that's being reflected back happens to be the green light, which is why the tree looks green. And now on my shirt, which is gray, the only wavelengths of light that are reflected back are the colors that would make gray, whatever mix of wavelengths that is. So when you see the color of something, you're only seeing what's reflected back. The rest is absorbed. And a prism, by the way, separates light into its separate wavelengths. All the light is coming from the sun. You put a prism out in the sun, you'll see it break the light down into the rainbow colors. In fact, a rainbow itself, water drops, separate the light. The sun shines when it's raining, and the raindrops will actually separate the wavelengths into the pattern. You will always see the same pattern because it goes from longer wavelengths of red all the way through Roy G. Biv to the shortest wavelengths of violet. Okay. Now the other end of the violet, ultraviolet. It's called ultraviolet because it's beyond the violet. That's what burns our skin. So sunburn. And there's a way that we use ultraviolet. It is used to radiate food to kill germs because it works. Kills germs. Okay. X-rays keep getting shorter wavelengths. X-rays are used to look through things like looking through your skin to see your bones. So, looking through things. Okay. Gamma rays, I'm not sure if there's really a use for gamma rays, but gamma rays definitely cause cancer because they're very bad for us. Causes cancer. That's one thing you can remember. Now, on our Earth, we are very lucky. Our atmosphere protects us from all of these bad things. They come from the sun. The atmosphere keeps them from coming down to our Earth. Gamma rays, X-rays, most of the ultraviolet rays don't even get through our wonderful atmosphere. A little bit of ultraviolet does get through, and that's why you get a sunburn. And then, of course, visible light. Yes, we see the light every day. And then infrared, heat, microwaves, radio waves, these all come through. But they're lower energy, and they won't hurt us. The only things that will really hurt us are from this end of the spectrum on. And luckily, we don't have to deal with them because of our atmosphere. So there you go. That's a little bit of a course on the electromagnetic spectrum. There's a whole lot more, but this is the basics.